This video is all about 3D similar shapes. Now those two cuboids are similar shapes because all of the sides are in proportion. This cuboid here, the lengths are 2 times bigger than the lengths over here. This length is 2 times bigger than that length. This length is 2 times bigger than this length. This length is 2 times bigger than this length. So the length scale factor is 2. Now notice I'm saying length a lot there, because I'm trying to avoid just saying that the shape is 2 times bigger, because it's a bit more complicated than that. For example, if I said that the volume of this shape was 100, a really common mistake would be for students to say that the volume of this shape would be 200, because that is wrong. The volume of this shape is not twice the volume of this shape. Only the lengths are twice as big. So this video is about how many times bigger is the volume of this shape. And similarly, we're going to look at the area, the surface area as well. So let's actually calculate the surface area of both of these shapes. So the surface area of this shape over here is 148 centimetres squared. And you can see the calculation I did there. I worked out the area of the front, which is 20. That's going to be the same on the back, 20. I worked out the area of the side here, which is 30, 6 times 5. That'll be the same as this over here. I've worked out the area of the top, which is 24, which is the 4 times the 6, and that'll be the same on the bottom. Add all them together, you get 148. And I did a similar thing over here. So I've worked out all the areas of each of these faces and added them all together and got 37. So straight away you can see that the surface area of this shape, that is not 2 times bigger than that. Similarly, if I did the volume of this shape here would be 5 times 4 times 6 is 120. The volume of this shape over here is 2.5 times 2 times 3, which is 15. Again, you can see that the volume is not twice. So how many times bigger is the area and the volume? So if we actually divide these, we can work out what the surface area scale factor is and the volume scale factor. So we've already seen that the length scale factor was 2. If I did 148 divided by 37, I would find that the area scale factor is 4. This is 4 times bigger than this. And if I did 120 divided by 15, I find that the volume scale factor is 8. Now you can see over here I've actually rewritten these just to show you the pattern. 4 is the same thing as 2 squared, and 8 is the same thing as 2 cubed. And this is always going to be the case. If my length scale factor is x, I'm going to shorten this, LSF, length scale factor, then the area scale factor is always going to be x squared. And the volume scale factor is always going to be x cubed. And I hope that makes sense, because if I have a shape, so if I have this rectangle here, and then this rectangle here, if they are similar, and if I make this length x times bigger, if I make the whole shape x times bigger, each length x times bigger, so if I make that x times bigger and that x times bigger, so this has got x times bigger, this has got x times bigger, so in terms of the area, it's going to be x times bigger, which is going to be x squared times bigger. Similarly, if I have a 3D shape, if these two shapes are similar, and if I make this x times bigger than this, and this x times bigger than this, and that x times bigger than this, then x times x times x, when I'm working out the volume, would give me x cubed times bigger. So hopefully this pattern here makes sense. So let's have a look at an example. So I've got 2 cylinders there. The height of the first cylinder is 10. The height of the second cylinder is 15. I'm told the volume of the first cylinder is 1000. I want to work out the volume of the second cylinder. So straight away, with the 10 and the 15, I can work out that my length scale factor is 1.5. Which means that the volume scale factor is going to be 1.5 cubed. So now I can do 1000 times 1.5 cubed, and that will tell me the volume of the second shape. Second example, I've got a triangle over here where this length is 8, a triangle over here where this length is 4. I want to work out the area of the smaller shape. So straight away I can look at these two and you can see that the length scale factor is just 2 here. So the length scale factor is 2. Each of the lengths here is 2 times bigger than over here, which means that the area scale factor would be 2 squared. So if I want to work out the area of the smaller shape, I'm going to do the area of the bigger shape divided by 2 squared, or divided by 4, which gives me 12.5. So when we are talking about the volume scale factor, it's cubed. When we're talking about the area scale factor, it is squared. Last example for this video, we've got 2 spheres there. This time I've been told the volume of the smaller sphere is 4 centimeters cubed, and the volume of the bigger sphere is 32 centimeters cubed. I'm told that the diameter of the small sphere is x, and I want to work out an expression for the diameter of the larger sphere. So with the 2 volumes here, I can work out the volume scale factor. You can see, I'm sure yourselves, that the volume scale factor here is 8. The volume here is 8 times bigger than the volume over here. So the length scale factor then, because remember the diameter is about the length scale factor would be the cube root of 8. It would be 2. So if the diameter here is x, the diameter over here will be twice as big, so twice x, so 2x. And this is my expression for the diameter over here.